Alright, welcome back. We're going to be doing BGP neighbor adjacency states now. Just like OSPF or EIGRP, BGP establishes a neighbor adjacency with other BGP routers before they exchange any routing information. Unlike other routing protocols, however, BGP does not use broadcast or multicast to discover other BGP neighbors. Neighbors have to be configured manually, and BGP uses TCP port 179 for the connection. In this lesson, we'll take a look at the different states when two BGP routers try to become neighbors. And they are, first one being idle. This is the first state where BGP waits for a start event. The start event occurs when someone configures a new BGP neighbor or when we reset an establishing BGP peer. After the start event, BGP will initialize some resources, reset a connect retry timer, and initiate a TCP connection to the remote BGP neighbor. It will also start listening for a connection in case the remote BGP neighbor tries to establish a connection. When successful, BGP moves to the connect state. When it fails, it remains here. The second state is connect. BGP is waiting for the TCP three-way handshake to complete. When it's successful, it will move on to the open sent state, which is state number 4. In case it fails, it'll move to active state, which is the third one. If the connect retry timer expires, it'll remain in the state. There's so many possibilities. This is like a stupid state to be in. But anywho, the connect retry timer will be reset and BGP will try a new TCP three-way handshake. If anything else happens, for example resetting BGP, then we will move back to idle state. Third state, active. BGP will try another TCP three-way handshake to establish a connection with the remote BGP neighbor. If it is successful, it will move to the open sent state. If the connect retry timer expires, then we move back to the connect state. BGP will keep listening for incoming connections in case the remote BGP neighbor tries to establish a connection. Other events can cause the router to go back to the idle state, such as resetting BGP. State number 4, open sent. In this state, BGP will be waiting for an open message from the remote BGP neighbor. The open message will be checked for errors, and if there's something wrong, such as incorrect revision numbers or version numbers, wrong autonomous system number, etc., then BGP will respond with a notification message and jump back to the idle state. This is also the moment where BGP decides to whether to use eBGP or iBGP. Since we're verifying the autonomous system number, if everything else is okay, BGP starts sending keep alive messages and resets its keep alive timer. At this moment, the hold time is negotiated. Lowest value is picked between the two BGP routers. In case the TCP session fails, BGP will jump back to the active state. When any other issues occur, expiration of the hold timer, for example, then BGP will respond with a notification message with a certain error code, and it'll jump back to idle. In case someone resets the BGP process, we also jump back to the idle state. State number 5, open confirm. BGP waits for a keep alive message from the remote BGP neighbor. When we receive the keep alive, we can move to the established state, and the neighbor adjacency will be completed. When this occurs, it will reset the whole timer. If we receive a notification message from the remote BGP neighbor, then we can fall back to the idle state. BGP will keep sending keep alive messages. Established. The BGP neighbor adjacency is complete, and the BGP router will send update packets to exchange routing information. every time we receive a key blind or update message, the whole timer will be resetted. In case we receive notification when messages, we'll jump back to the idle state. This whole process of becoming BGP neighbors can be visualized. This might be a bit easier than just reading about it. The official name of this type of diagram would be a FSM, or finite state machine. For BGP, it looks like this. So we have idle, that can only move in one direction, which is connect. Connect can move back to idle, can move to active, or move to open set. But I think it could also remain in connect. Is that what I read? Oh, I guess it was another one. Alright, so OpenSet could either go to idle or it can go to open confirm. Open confirm, same thing, can either go to idle or it'll be established. Cool. Now you know about the different states. Let's take a look at some Cisco BGP routers to see what it actually looks like. Alright, it looks like we're using the same topology as last time. So I already have everything. Sweet. Alright, let's open up this terminal. For debug, BGP. Alright. Terminal. Well, I already did that. Okay, so I'm probably not going to see anything because the neighborhood relationship had already been established from before, so I gotta maybe do a shutdown and no shutdown. Router BGP 1. Neighbor 192.168.12.2. AS2. Shutdown. Sweet, there we go. So I'm getting some messages now. Well, yeah, this is kind of weird. Put no up here. Alright, so. Alright, we're waiting for this message, but it doesn't seem to be appearing. Maybe one of the routers has to reset. Go over here, I will shut this one down, or it appears that I shut it both down, but that works as well. Is it even up? It is up. So I missed out on all the log messages. Kind of sucks. But I thought there was a way to like only shut down one node. Okay, there we go. I think now we should be able to see all these log messages. Nope, it skipped out on all of them. I think it might be because I don't have the debug on anymore. Oh, okay, that was why. Alright. Okay, here we go. Okay, so went from active to idle, that's right here. Went from idle to connect. Idle to connect. Receive message length, or message type 1. Receive open. Version 4 of BGP with hold timer of 180 seconds. Went from connect to open sent. Alright, and then yeah, same type of message. Open has capability code 1 with length 4. It exchanged a couple things, and then it went from open sent to open confirm, then open confirm to established. Alright. Now you know about the different states, let's take a look at some Cisco BGP routers to see what it actually looks like on two routers. Oh wait, I already kind of did this. As soon as I configure BGP on R1, it will try to connect to R2. You can see that in the debug menu. When it says it's moving from idle to active, which we went through, and it fails, it goes back to idle. And this is pretty much going to show the same thing. Above you can see that BGP state moves from idle to active, then to open sent. Some open messages are sent and received. The BGP routers are exchanging some of their capabilities. From there we move to the open confirm and established states. Finally you will see BGP neighbor as up. Alright. The output of these debug messages are nice and easy to read. If for some reason your neighbor adjacency doesn't appear, these debugs can be helpful. Alright, I think that's it for this lesson.